Today we saw that the current there will go, the whole current will pass through the 4, then the current will split up into 2, 1 or 3 because the voltmeter's resistance is too high, it cannot pass through there. Then it goes back and all of it goes through the ammeter again. Then my sandwiches, my energy, my volts splits up into 2. Alright. Then the first question there was calculate the banner. And 40, and Emil, when you leave, you must take your box. Right. So yesterday the first question was what is the total current? And we said, okay, the total current there, we need the total volts and the total resistance. Total volts was easy peasy. Total resistance was not that easy. We first had to determine the resistance in parallel, that we got to be 2. And then we added the resistors in series together, so the total resistance was 6. So then we said, all right, the total current then will be 12 divided by 6 gives us 2 amperes. Okay, that was the first question. Now the next question was, what is the reading on V1 and V2? So we said, okay, on V1, what does it measure? It measures the volts, the energy needed just for the 4 ohm resistor. Nothing else, just the 4 ohm. Where's your notes? Move, right, because you missed a lot. Alright, so we need the volts for the 4 ohm resistor. Okay, so we said, right, for the 4 ohm, what is the current that passed through there? We saw that the total current passes through there, which was 2 amperes. So I said the total current is 2. Alright, it's 2 amperes. Then the resistance for the 4 ohm resistor is 4 ohms. So if I want to get the volts, so that is the formula. The resistance is 4 volts. We want to get, the current is 2. You take it to the other side, it becomes multiplied, and you get 8. So what does that mean? It means of your 12 sandwiches that you have, 8 of it goes there. How much do you have left for this? 4. All right. So the question of what is the reading on V2, I'm going to say that V2 is 12 minus 8, and that gives me 4 volts. Why did you not write anything yesterday? All right. Then the last question is calculate the current through the 3 and the 6 ohm resistors. So they want to know of the 2 amperes, how much goes there, how much goes there. And we said yesterday, we think because this resistance is smaller, that the bigger current will go through there. All right. Yes? We did a similar question yesterday here, where we said, what's the current in each branch? Okay, now this is a long way to do it. Today I want to show you a shorter way, but a bit more difficult. Okay, but a shorter way. What else did I want to say about that? But this way that I'm going to show you, you can only do when you have 2 resistors in series. When you have 3, you cannot do this method. Only when you have 2 resistors in series. Did you make a note of that? No, you lie. You are sleeping. Only do when 2 resistors, not in series, in parallel. All right, so what you're going to do, only do when 2 resistors in parallel. All right, so This is question 3. Where is what? The method. I'm going to do it now. I'm waiting for everyone to just wake up. You are grade 10. You're almost 16 or you're already 16. You must listen and write as I speak. You're not in grade 8 where I say, let's write together. Do what I say. Right. So what you're going to do is you're going to say, the two resistors that I have in series is 3 and 6. So you're going to write 3 versus 6. Okay, can I zoom in there on the right hand side? Then when you add 3 and 6 together, what do you get? 9. Okay, so your ratio that you have is 3 over 9 and 6 over 9. That's your two ratios. 3 over 9 and 6 over 9.
Sorry.
Yes.
Is that 4 ohms?
Yes. Right. So 3 over 9 and you have 6 over 9. That's your ratio. Okay. Of what? What is question 3? They ask to calculate the current. So through one branch it's 3 over 9 of the total current, and the other part it's 6 over 9 of the total current. What is the total current? We calculated it there to be 2. So times 2 and times 2. So maybe highlight it for yourself. Where did we find that 2? That 2 we got there. Because I promise you, when you get to June exam, you'll have no cooking clue where we got the 2. Alrighty. Well, we're going to start. So there you go. Calculations. Scientific. No, it doesn't have to be scientific. It can be, but it doesn't have to be. Yes. 0.6, and if you round off, 6, 7. Okay, and the other one, Khali? Get your calculator out. And that is 3. Kumo, when you add these two values together, what do you get? What did I say 5 minutes ago? Not 5, 1 minute ago. Take out your calculator. And then I asked you, is your calculator out? Borrow hers. It is 2. Why is it 2? What happens with the current there? It splits up. What was the current? It was 2. Right? So it's obvious that you add all of that and all of that together, it must give you 2. Sharp. So that's how you can check yourself. Did I do this something right here? Now the question is the current, sorry, don't do that, is the current through the 3 ohm resistor, why do we have a 3 there? Because there's a 3 there. So is the current through the 3 ohm resistor 0.67? Is the current, now I'm asking the whole class, the current through the 3 ohm resistor 0.67? Who says yes? Put up your hand. Who says no? Are you in or are you out? Make a stand, Ntando. The no's are correct.
Thank you.
But why, Carabello? Why is it no? Then what did we just do? Why is the current through the 3 ohm resistor not that? Yeah. Courtney? Thank you very much. I said somewhere today, remember, we thought that when the current splits up, the bigger current will go through the smaller resistance. So for yourself, you make a note. You say, all right, I'll make a note for myself. I remember that current is inversely proportional to the resistance. The bigger the resistance, the smaller the current. Inversely proportional to one another. I think you've heard that word about 100 times in this class this year. Right, so they are inversely proportional to each other. So that means that the current, so I'm gonna almost like crisscross that with one another. The current through the 3 ohm resistor is 1.33 and through the 6 ohm resistor is 0.67. So I'm going to say the current through the 3 ohm resistor is 1.33 amperes and the current through the 6 ohm resistor is 0.67 amperes. Die video's kijken.
Ja.
Yeah. All right. So, right. You all get that? Someone I must say that again to Manu. Yes, again. All right. So we said, let's look at that in a different way. We said yesterday, let's say that is English and math lit and math. Right? Everyone must take English, no choice. But when you give people a choice between math lit and math, what will they choose? Math lit. Because it's easier, less resistance. So we think if we have 100 people, that about 60% will choose math lit and about 40% will choose math. So more people, the bigger current, more electrons will go through the smaller resistance. That is why we said that current, the number of people, is inversely proportional to the resistance. So when I did this calculation here, I said, all right, the smaller resistance must have a bigger current. Okay, so the current through the 3 ohm is bigger and the current through the 6 ohm is the smaller one. So they will always crisscross. Chop. Right, so what I want you to do now is on page 8, I just want to check the time. I want you to do question 1. What time? Does the bell go? This is period what? Just give me a moment. For real, it's period 2. Oh, I see. All right. No, I think it's a bit longer. I don't even look at the time. 30 minutes. All right. No, we're not going to waste time discussing what. Yeah. All right. So let's read together. It says, 2 cells are connected in series to a switch, a 4 ohm resistor, and an ammeter and a parallel combination of 2 identical resistors. The ammeter reads 2 amperes, and the potential difference across the parallel resistors is 6 volts. Now they ask you to draw a circuit diagram. So open your writing books, please. Okay. Now, when I ask you to test your exam to please draw the circuit, you do not. we don't ask that a lot in grade 10 because it's a bit grade 9 work. But when I ask you don't have to draw it in pencil, you can draw it in pen, but you don't have to draw it in pen, you can also draw it in pencil. When I ask you to draw it, please use a ruler and then use don't make circles, ne? Use square corners. Right. Yes. Yes. If you see there, the answers to the questions are given. So you can check yourself if you want to work ahead. Alright. So we are going to draw. So your heading there is the worksheet on page your 8 as well. This is electricity. And today is the 16th of the 3rd. Yes. No, you'll see I don't care about that. You use your book. Say again? Right. So, question 1. They say 1A. 2 cells in series. 2 cells in series. 1, 2. You can draw it the other way around as well. So the longer one on the right hand side, shorter left, doesn't matter. Then they say we have a switch. Your switch does not need to be open. It can be closed as well, but it can be open if you want to draw it open. Then they say we have a 4 ohm resistor. Then they say we have an ammeter. Then they say we have a parallel combination of 2 identical resistors, but they don't tell us what they are. So I'm just going to make them X and X. You can make them Y and Y, A and A, R and R. Okay, that's all they say. Then they give us extra information. But you obviously need to close your circuit, yes? Otherwise, nothing will happen. Duh, the circuit is not completed.
When did you say that?
Yes. Right. They also tell us that the ammeter reads 2 amperes. And then they say the potential difference over the parallel combination. So potential difference is measured with what again? With a Khali? A voltmeter. And a voltmeter is connected in parallel. So they say if you were to measure with a voltmeter there, then it would read, they say, 6 volts. Right. Then I'm going to take my highlighter. And I'm going to think, where do the current go? Okay, so here they walk. Do, 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 do. Everyone passes through the 4 ohm resistor. They have to. So the 4 ohm, the whole current, the total current passes through the 4 ohm resistor. Yo, Relo, do you have space there with Muau? Going over to your son. Alright, we will go on the next